Hi everyone, welcome to part 2 for our video recordings on section 3.5 dealing with the derivatives of trigonometric functions. In this video, we're mostly going to be going over different types of examples involving the derivatives of trigonometric functions. So let's go ahead and begin with this first function where we're being told that g of t is equals to t squared times the cotangent of t. So what would be this derivative? Now, the last problem on the previous video, we encountered a problem involving the quotient rule, but this time around, we are multiplying two functions, the t squared times the cotangent of t, which means that we need the product rule. So here we have the product rule, which was telling us that if you're taking the derivative of two functions that are multiplying, then the derivative will be the derivative of the first times the second plus the first function times the derivative of the second. All right, so let's go ahead and take a look at this problem. Which two functions are we multiplying? Well, we are multiplying a t squared, so I'm going to call this one here my f, and the cotangent of t, which I'm going to call this one here my g. So listing them out here, let's go ahead and find the respective derivatives. The derivative for f is going to be involving the power rule, so f prime is just going to be 2t. Now what about the derivative of g? What is the derivative of the cotangent function? Well, I'll let you guys take a look at the previous pages to take a look at those derivatives, but the derivative for the cotangent is going to be a negative cosecant squared of t. And there we go. We found the f and the g and the respective derivatives. So now it's just a matter of putting it into our product rule. So the derivative of the whole function, g prime of t, is going to be equals to 2t times the cotangent of t plus t squared times a negative cosecant squared of t, which I'm just going to go ahead and write here as 2t cotangent of t minus t squared times the cosecant squared of t. And that's it. We found the derivative for the original function g. Now it is true we can go ahead and factor out a t, but it's not going to simplify the problem too much, so I'm just going to leave it as is. Okay, now let's take a look at the next problem here, where we have the function y equals to sine of theta plus cosine of theta all over cosine of theta. Now, at first glance, this problem seems like a problem that requires us to use the quotient rule, which to be fair, we can use. However, I'm going to keep on emphasizing the point that I discussed in class. If you can do some algebra first, do some algebra first, and then take the derivative. So what I noticed for this one is that I have two terms in the numerator, but only one term in the denominator. So rather than finding the derivative first, I'm going to see if I can simplify by dividing both terms on my numerator by my denominator being the cosine of x. So using algebra first, I'm going to get y equals to the sine of theta over the cosine of theta, okay, plus the cosine of theta over the cosine of theta. And I do notice a couple of things here. Well, for starters, I'm dividing a cosine by a cosine, which is just going to give me a 1. But I also see a sine over cosine, which I recognize as my tangent function. So y is actually simply the tangent theta, or tangent of theta, plus 1. Now, if I want to take a derivative, this is a much simpler derivative to take care of. So let's see, what would be the derivative for function y then? Well, y prime is going to be equals to the derivative of the tangent, which we know that it is a secant squared theta plus the derivative of 1, which is a constant, so it's 0. So there we go. This is our final answer. Y prime is simply the secant squared of theta. Now, what if you used the quotient rule? Could you still get the same answer? Yes, but the process would have been longer and the simplification would have been more complicated. So I always say, if you can simplify at the beginning, simplify at the beginning, so you start off with a simpler problem. Okay, perfect. Now let's take a look at the next function here, where we have y is equals to a cosine squared of x. So what is this derivative? Now, at first glance, this might seem like a problem where we don't really have the tools at our disposal to figure out this derivative, because we've seen the derivative of the cosine, but not the derivative for a cosine squared. So what can we do? Well, just as we did in the previous problem, we can go ahead and use algebra first and rewrite the problem here, not as cosine squared of x, but instead as the cosine of x times the cosine of x. Now I actually do have a product, and we can go ahead and use the product rule once more. Okay, so let's go ahead and identify which functions are we multiplying. Well, we are multiplying a cosine, so that's going to be my f, but we're also multiplying times another cosine, so that's going to be my g. So simplifying out that derivative, or figuring out what is the derivative for the cosine. Well, the derivative for the cosine, we just said it was a negative sine of x. So putting everything together into our product rule formula, we're going to get y prime is equals to a negative sine of x times a cosine of x plus a cosine of x times a negative sine of x, which can be simplified here as a negative sine of x cosine of x minus a sine of x cosine of x, which is equals to a negative 2 sine of x cosine of x. And there we go. We found our derivative function. Perfect. And again, the key here being, gotta use algebra first. Okay, so let's take a look at another problem here to keep on getting practice. All right, so the next function, we have h of x is equals to e to the x times the cosecant of x. Now this problem here, notice that it is also dealing with the product between the function, the e to the x times the cosecant of x, so which means that we will need to use a product rule. Well, this one though, I'll let you guys practice on your own and submit your answers on Canvas. And again, remember what's the function f that you're multiplying and what is the function g. All right, now I want to go ahead and take a look at higher order derivatives. So let's practice here with two examples where we're trying to find out the second derivative this time around. Beginning with the first one where we have y is equals to x times the sine of x. So what is my first derivative? Well, once more, I am dealing with the product of x times the sine function, so we'll keep on using the product rule. Now for this one though, I will not go ahead and write down the product rule, although I will encourage you guys to write it down, and I'm just going to go ahead and identify my functions first. In this case, f is the x, and g is the sine of x function. Okay, so what are the respective derivatives? Well, f prime is just going to be a 1, and my g prime function is just going to be a cosine of x. All right, so putting all the pieces together into our product rule, then we're going to get here y prime is equals to 1 times the sine of x plus x times the cosine of x. So this is our first derivative, but now we're looking for the second derivative. Okay, so I'm going to go ahead and give myself a little bit of room here. Now what about the second derivative? Now because we're finding the second derivative here, we have to identify a new f and a new g. All right, so going back to a first derivative, I'm just going to clean it up a little bit more. I'm just going to have as my first term simply the sine of x plus an x times a cosine of x. All right, then for our second derivative function, now I'll put in the in-between step here. We're going to be taking the derivative of the first derivative, so it means that I will need to find the derivative for the sine of x and the derivative for the x times the cosine of x. And this is where we need the product rule again. So once more, I'm going to go ahead and identify my f and my g. So f is x, so f prime is just going to be a 1, and the g is the cosine of x. So the g prime here, and this is where we got to be careful, that the cosine is a negative sign. Okay, so putting everything together then, what would we get? All right, let's see. We have the derivative for the sine function, which we know it's a cosine of x, plus now the derivative for the x times the cosine of x, and using the product rule, we're going to get 1 cosine of x plus x times the negative sine of x. Now simplifying this one here a little bit more, we're going to get the second derivative is going to be equals to, well, I do see that I have a cosine of x plus another cosine of x, so we'll get a 2 cosine of x. Then we have an x times the negative sine of x, which is going to be a negative x sine of x. And there we go. We get the second derivative function for the x times sine of x. This one here is our final answer. Not much that we can simplify. Okay, now let's take a look at another problem involving a second derivative. What about the tangent function? What is the second derivative for the tangent function? Well, this one here is just a regular tangent function, so there's no product, no quotient rules involved. I'm just going to go ahead and reference the fact that I know that the first derivative for the tangent function is going to be equals to the secant squared of x, which I know I can go ahead and rewrite as the secant of x times the secant of x. Okay, so what is the second derivative for the secant squared of x? Well, that's just going to be equals to our derivative for the secant of x times the secant of x, which now is involving a product here. So we're going to go ahead and need the product rule. Okay, so once more, identifying the functions that are multiplying, put here the f is the secant function, and the derivative for the secant function is going to be a secant times a tangent of x. Now, because the g function in this case is also another secant, then we just go ahead and repeat the derivatives. So g prime is going to be equals to secant of x times tangent of x. All right, so putting everything together here, and again, using the product rule, we're going to get secant of x times the tangent of x times the secant of x plus another secant of x times a secant of x times tangent of x, which we can go ahead and simplify here as 2 times, let's see, a secant times a secant is going to be a secant squared of x times tangent of x. And there we go. We're done here with our second derivative for the tangent function. Perfect. Now, I want to go ahead and take a look at one last problem, and it's a problem similar to the ones that we've been doing. What about a problem where we want to figure out what are the points between the measurements, or the angle measurements here from 0 to 2 pi, where the following function, cosine of x plus the square root of 3 times the sine of x, has a horizontal tangent. Okay, well, once more, if we see a horizontal tangent, that means that we're looking for the places where the derivative is equal to 0. So, or in this case, or y prime is equal to 0. So what are going to be these x values? Okay, well, let's go ahead and start by finding out the derivative. All right, so here is our derivative function. I haven't found the derivatives yet, but wrote out the correct notation. So let's see, y prime is going to be equals to the derivative for the cosine, which we know it's going to be a negative sine of x, plus the square root of 3, which is constant. I took it outside the derivative. So plus a square root of 3 times the derivative of the sine, but we know that the derivative of the sine is a cosine of x. All right, so this is equals to 0. Okay, so what are we going to get here? Well, let's take a look. We're going to get the following equation. I'm going to go ahead and add a sine of x to both sides of the equation, which is going to give us a square root of 3 times the cosine of x is equals to the sine of x. Now, what can we do here? Now, at this point, there are different paths that we can take, but I'm thinking that we can go ahead and divide by a cosine of x to get all the variables or all the unknowns on one side. All right, so now that we divided by the cosine, we're left with the following. The sine of x over the cosine of x is equals to a square root of 3. Now at this point, you do recognize that we have a sine of x over a cosine of x, which is exactly the same thing as the tangent of x is equals to a square root of 3. Now the question is basically asking us, okay, so for what angles is a tangent equals to a square root of 3? Now for this one here, you can go ahead and reference a unit circle. I'm just going to go ahead and make a quick little sketch here. And it turns out that the angle whose tangent is square root of 3 is actually the pi over 3. So our solution then is going to be equals to, in fact, let me move this a little bit here. So our solution here is going to be equals to x is equals to a pi over 3. Now, is this the only place on the interval from 0 to 2 pi where the tangent is rad 3? Well, turns out here that, yeah, it's not actually the only place, because if we actually kept on going here to the third quadrant, there is going to be another coordinate points where we're going to have a negative 1/2 comma negative rad 3 over 2, whose tangent is also going to be equals to rad 3. Now, which is this other angle? You can go ahead and reference the unit circle, or alternatively, if you remember that the period for the tangent function is pi, well, what we can do here is simply take our answer that we have here and add a pi to get the other place in the unit circle that has a tangent value of pi over 3. Sorry, of rad 3, which in this case is going to be equals to a 4 pi over 3. And I'll put it right over here. You're left at the 4 pi over 3 here. There we go. So this ones are the two solutions on the interval from 0 to 2 pi. So as you get to see here, guys, yes, we are finding derivatives for the trig functions, but that doesn't mean that we're not going to be solving some trig equations. We will. So it's always handy to have the unit circle nearby, or again, remember the first quadrant of the unit circle, and then use reference angles to figure out the remaining angles or the remaining sine and cosine values in the unit circle. Okay, so this is it for this part of the recordings, but again, I do want to emphasize that on the exam, yes, you might be able to, or you might need to, solve a trig equation. Okay, so this is it for this recording. I'll see you guys in the next recording dealing with another very important rule known as the chain rule. I'll see you there.